So this short video here will start off detailing the SOLIDWORKS model for 2015 question A3. So you have to draw the plan and elevation of the line of intersection and determine the dihedral angle between the two planes ABC and ADE. Now you always want to use your 3D diagram for the best help for you. A is a common point between the two planes, so the line of one point of the line of intersection has to be on A. And if you look in 3D here, the bottom of the line of intersection is on the base here, and it's basically where line BC and DE cross, so that's a point on the line of intersection. So it's essentially going to be this joined to A. So if I show you the SOLIDWORKS model here, okay, there's the planes, okay, the green and red, and if I zoom in here, the two planes, okay, they're crossing, the line of intersection between the two surfaces are literally crossing on that point of intersection here in plan. So that is the line of intersection. Okay, and I'll prove that to you by, if I just look here in elevation, so you can see the computer generating it itself, and then down in plan, the line of intersection is between them. Then to get the dihedral angle, alright, we're going to have to look along the line of intersection here. So here's the line of intersection between them. And if I want to see the dihedral angle between them, I need to see that line of intersection as a point. And in order to get that, I'll have to look along its true length of the line of intersection. So we'll have to find the true length in our drawing sheet, as you cannot get it. Otherwise on a drawing sheet without looking along its true length. So there's the line of intersection as a point, and that's the dihedral angle between the two surfaces. Then we're asked to find the traces of the plane containing ADE. So we're asked to find, where does ADE pierce the vertical plane? So where does it pierce the vertical plane, and where does it pierce the horizontal plane? So we're asked to find that. So we've got one line here, DE on the XY line. So the trace of the plane ADE is going to be the horizontal trace is going to be an extension of that line. Okay, there's the traces there, and as I said, the horizontal trace is longer. To get the vertical trace, so where the plane meets the vertical plane, we're going to, in plan, draw a line parallel to the HT until it hits the XY line in plan. So that's essentially hitting the VT, and then we're going to go straight up. Then from that point in elevation, we're going to go straight up, and then we're going to go parallel to the HT in elevation, so parallel to the XY line. Where they intersect, that's a point on the trace. So that's what we're going to do. Okay, so the line of intersection, okay, is A in plan is A to this point here, where BC crosses DE, because as explained on the 3D model, these are on the horizontal plane, these two, and they cross each other, and they're on what you call it, the end point of the line of intersection. So I'm going to join A to D, LOI, and then I need to find that point in elevation. So I'm going to bring the point straight up. There's F. Now, F joins to A in elevation. Right, in order to see the dihedral angle between the two surfaces, we need to see the line of intersection as a point. And a line only appears as a point when you look along its true length. Is the line AF already a true length? The answer is no, because it's not parallel to the XY line in either view. So I'm going to look perpendicular to the line AF. So I line my set square up with the edge here, slid along, okay, with another set square T square underneath. And I'm taking an auxiliary elevation of the line of intersection, and I'm projecting all the points there. Now, I'm going to take the heights, okay, from elevation. So all I need to do is take the height of A, because all the other points are on the XY line in elevation, so they'll be on the X1, Y1 line in the auxiliary elevation. So I took the height of A here with my compass. I'm going to find A here, mark it there. So there's point A1, E1, B1, okay, F1, C1, and I have D to do there as well. So D1. Now, these all join to point A. Now we're going to look along our line of intersection A1, F1. So I'm going to look along that line there and project a second auxiliary. So all the points are projected parallel to line A1, F1. And my X2, Y2 line is going to be perpendicular to that. I'm going to take my distances from my X1, Y1 line back to plan. So I'm going to take the distance here of A1 back to plan, follow it along here, plot it here. Here's F2 slash A1. Then I'm going to take the distance of B. All I need to do is a point on each surface. Okay, so B. So there's B2 there. And then D. I don't need to bother with C and E because the surfaces should appear as edges. There's C2, and then this be E2 here. So this is the dihedral angle between them. And then it's a good idea to mark it, or to label it and measure the value, and then we'll do the next part, or part B. So 75. Now, to find the traces of the plane DE as per the SOLIDWORKS model, okay, all we have to do is extend line D to E, because it's on the XY line in elevation. So there's the HT, and then we're going to draw a line parallel to A, or parallel to the HT in plan from A. And then where it hits the XY line, we're going to go vertically up, and then from A we're going to go parallel to the XY line in elevation. And there's the VT. Cheers, thank you, bye bye.